Hi everyone, welcome to this session. My name is Somajit. In this session, we are discussing a very interesting question from time, speed, and distance. In this question, there is a typical format: a car engine, after traveling some X kilometers, develops a problem, thereby reducing the speed and reaching the destination late. This is a very standard template of the type of questions that has been tested in the CAT previously. This is also deemed as a difficult question type. Okay, now there could be many methods to solve these type of questions. Today particularly I will give you two methods to solve this question. One is logical way and the other one is equation method. Equation way is going to be a little more time taking, but I'm telling you one thing: if you just watch this video in its entirety and give it the respect that it deserves, you will understand the nitty-gritties of these type of questions, and every time you will be able to solve these type of questions, at least with the equation method. Logically also these can be solved in less than 1 minute, but then again I have seen this thing in my past experience that students are not very well equipped with the logical method. They understand it, but they are not able to apply it in an exam setup. So with all that in my mind, now let us look into this question. I'll just zoom out a little bit for solving. Let's read it first. They say that there is a car traveling 28 kilometers. After traveling 28 kilometers from a point A, developed some problem in the engine and the speed became 4/5 of its original speed. As a result, the car reached point B 45 minutes late. If the engine had developed the same problem after traveling 40 kilometers from A, then it would have reached B only 36 minutes late. The distance between point A and B is, obviously in kilometers they are asking, right? So there are many things that we need to look into this question, but typically what I can understand is that let's make sense of the data. There is some point A, there is some point, let's say C, and some, so this is 28 kilometers. Okay, there is a engine problem happening at location C, and thereafter the speed is reduced. Okay, we can assume some variables. Of course, I would say that if original speed is to reduced speed is S1 is to S2, I can write it like S is to 4 5 of S. Can I cross multiply? So this is basically 5S and S. I know you guys are very smart, you have understood it. So this part is 5S and this part is 4S. Okay, sort of the distance is constant between A and B, so the speed and the time will be inversely proportional. That is what I know from my previous knowledge. So speed is inversely proportional to time. This is one of the ideas that I have, and just to make your life easy, time into speed is equals to distance. This is the only formula in time, speed and distance. Okay, now the next case says exactly everything same, but there's a slight change. Instead of this C juncture at this point, okay, the train developed the snag at C dash, which is at a 40 kilometer stretch. You can see from A to C it is still 28 kilometers. I hope that is clear, right? I have additional 12 kilometers in my arsenal that I am traveling at my usual speed. So far so good, and I don't know about the other part. So I can say that this much I'm traveling at 5S and this much I am traveling at 4S speed. Hope that is clear. Now please pay attention. In the junction point this C to C dash, the 12 kilometer, you can see the first case I am late by 45 minutes. The next case I am late by 36 minutes. There is a gap of 9 minutes. And what does this gap represents? This gap represents that if I would have traveled this 12 kilometer in my usual speed, I would have saved 9 minutes. Is it not? Because otherwise I would have been delayed by 45 minutes. Now I am delayed by 36 minutes. So there is a 9 minute ka saving that has happened. And why does this saving happen? Because I have traveled 12 kilometer at my usual speed. So the logical way says that if I travel 12 kilometers at my usual speed, I am able to save 9 minutes. So what distance should I travel at my usual speed for the first one to save 45 minutes? Just multiply a 5 over there, a 5 over there. So this becomes a 45, this becomes a 45, and this becomes a 60 kilometers. So that means if I travel 60 kilometers at my usual speed, I will be 60 kilometers at my usual speed, I would have saved 45 minutes. Now this is logically how you can solve this. Okay, this is very easy, and but I am still sure that there would be many students who would not be very happy. So the answer to this would have been 88 kilometers. From A to B, what is the distance? 28 and 60, 88 kilometers. But as I was telling you, that again many students would not be very happy with this method. So what can we do? Is there a method that I can use to solve this, let's say with making some equations? Yes. Now let's make some equations and try to solve it. So what I will do is, for that please understand one thing that is very crucial to solve this question. The delay of 45 minutes in the first case and the delay of 36 minutes, why does this happen? Please understand this very carefully. The delay is happening because this distance in the first case is traveled at a reduced speed. If I would have traveled at the usual speed, I would not have been delayed by 45 minutes. That means because the speed has reduced, the time has increased. Okay. So for the distance, which distance? This distance, the what is the time that I will travel at my usual speed subtracted from the time that I am traveling at my reduced speed. Okay, if I have to mathematically, this is logical, but if I have to mathematically tell that to you, so whatever is going to be T2 minus T1, what is T2 minus T1? T2 minus T1 is 45. This is my equation number 1, and over here in the next case it will be T3 minus T4 minus T3 is equals to 36. These are the two equations that you will be solving and you'll get the answer. What is T2 minus T1? Time 2 is the reduced speed, time 1 is the usual speed. Now please pay attention to one thing, otherwise you will be very much confused. Which time is more? Think about it. The time that is traveled at the reduced speed is going to be more. That means if I assume the total distance over here, let's say, to be d, from A to B the total distance to be d. So I know this much is d minus 28 and this much is d minus 40. So I have the distance, I have the speed. Can I calculate? Of course. Again I'm telling you, time is equals to distance upon speed. Remember this thing. Okay. So now we will use it. This is for the first 5s and 4s. Okay. As I told you that the time that has been the time due to the virtue of the reduced speed is going to be more. Is it not? Speed is there inversely proportional to time. So speed is more, time is less. Speed is less, time is more. Here speed is less, so time will be more, and that is why the subtraction makes sense. Okay. Otherwise you could just do, play with the arithmetic and you can get the same answer. It's just I'm just trying to tell you that the negatives need to make sense. Okay. Now what do I need to do? Just take d minus 28 common. This is going to be elaborate, I'm telling you. Okay, this will take some time, so please pay attention. D minus 28 common, so this is 5s minus 4s upon 20s square. Now this is going to be 5s minus 4 is s upon 20s square is going to be 1 upon 20s. Okay, that is equals to 45. So d minus 28 is going to be 45 upon 60. Remember, this is in minutes, so dividing this by 60 will convert it into hour. We need the kilometers, right? So when I am equating kilometers per hour, distance in kilometer, speed in kilometer per hour, the time also needs to be in hour, because otherwise it will be a mismatch. So 45 by 60 into 20s. You can keep this in this thing, plus 28 is equals to d. Okay, d is equals to this. Now this is my first equation, and if you are a little smart, you will realize I'll have another equation also, similar equation. And what will that be? That is going to be d is equals to d minus 40, sorry, d is equal to for 36 upon 60 into 20s plus 40. Okay, this is exactly what you can do on your own also. These are the two equations. In both the cases, distance is same, just equate the two equations. Okay, so I will try to do this a little mentally. Let's see if you can catch it. So this is going to be 40 minus 28, that is 12, and this part is going to be, hold on, 45 upon 60 into 20s minus 36 upon 60 into 20s. So this cuts, this is 3, this is 12, this cuts, this is 3, this is 15. 15s minus 12s is 3s. 3s is equals to 12. This means that s is equals to 4 kilometers per hour. Hold on. The speed that I am getting is 4 kilometers per hour. But remember, we have assumed the total speed to be 5s. Okay, so the total speed would have been 20 kilometers per hour, and the reduced speed, that is going to be 4/5 of this, is nothing but 16 kilometers per hour. Okay, now you may be thinking that, sir, how does this help us in calculating the distance? Now since we have gotten the value of s, just plug it into any one of these equations, 1 or 2, you will get the answer. So let's plug that into the next equation. So it is going to be, let's do it with a different color. So d will be 36 upon 60 into 20 into 4, remember s is 4, plus 40. So 0 and 0 cut, this is 3, this is 12, 12 fours are 48, and 48 plus 40, that is equals to 88, and this is what we have gotten in the first case also. Okay, logically when we were solving it, logically also we were getting 88 kilometers only. So the answer to this question is 88 kilometers, and this much amount of insight you have to put into these questions if you really want to get ahead in your preparation. This is just a snippet of the amount of work that one needs to do in order to excel in their tests. Okay, if you're interested in getting mentored under me, the Trident banner, you can get in touch with me through the available links. If you like the video, please subscribe, like it, and if you have any queries, you can put that down into the comment section. I will be more than happy to look at it. Thank you. This is me, Somajit, signing out.